Today I'm going to talk about operating system structures. Now, first we have to explain the operating system is. An operating system is an interface between user and computer hardware. It helps the computer and user work together. For example, Windows, Linux and Android. Now, coming to operating system structure. Structure means how the operating system is arranged inside. It shows how programs, system parts, and hardware are connected. Let me explain them one by one very simply. First is simple structure. As the name says, it is very simple. Here there are no clear layers. All parts of the OS work together in one place. In the diagram, we can see application program, system programs, device drivers, and BIOS. They are directly connected. Advantages of simple structure is very fast, easy to create and understand, good for small systems. And the disadvantages of simple structure is no proper security. If one part fails, the whole system crashes. And the example of the simple structure is MS-DOS. Now, let us see the monolithic structure. In this structure, the entire OS works as one big program. All services like file management, memory management, device drivers are placed inside one kernel. Advantages of monolithic structure is very high performance, fast communication between services. Disadvantages of monolithic structure is difficult to debug and modify. If one error happens, the entire system crashes. Examples of monolithic structures are Unix and Linux.
Here, I am explaining about the layer structure. Layer structure is a way of designing an operating system by dividing it into several layers. Each layer performs a specific function and communicates only with the layer directly. This structure follows a hierarchical organization, starting from hardware at the bottom and user interface at the top. Now we can see the structure. In this, top layer represents user interface, middle layer represents files, I/O devices, memory management, and bottom layer represents kernel and hardware. Now I am telling how it is gonna be working. User requests code to top to bottom. Then result returns bottom to top. It cannot direct access to hardware by user. In this, easy debugging is the one of the advantages of layer structure. It is mainly each layer can be tested independently, and slow performance is the disadvantages of layer structure. Request must pass through many layers. Here one of the example is the operating system. For all this, it can be telling layer structure gives a clean and systematic OS design, best for learning and structure system. Microkernel structure. A microkernel structure is an operating system design approach in which only the most essential functions run inside the kernel, while most other services run as a separate user level programs. In this, we can see the structure of microkernel. It tells us how it can be working. These three are the key aspects of microkernel structure. First, minimal core. The kernel is small and lightweight. It handles only critical tasks such as basic memory management, inter-process communication, CPU scheduling, and services like file system, device drivers, scalability and security. Each service runs independently. If one service, for example, the rest of the operating system continues running. This results in a highly stable and secure system. And performance trade-off. It communication between services requires message passing. This causes additional communication overhead. As a result, perform may be slightly slower compared to monolithic kernels. One of the advantages of this high reliability and security and disadvantage is performance can be slower due to frequent message passing. For example, Minix and Match. From all this, microkernel structure improves system stability and security by keeping the kernel minimal, but it may reduce performance due to communication overhead. My friend will be continue the next.
The modular operating system structure is an extension of the monolithic kernel design in which the operating system is divided into a core kernel and a set of loadable modules. The core kernel provides essential functions such as process management, memory management, and system calls, while other functionalities are added as modules. In this structure, modules like device drivers, file systems, and network components can be loaded or unloaded dynamically while the system is running. This means the system does not need to be restarted to add new hardware support or features. As a result, the kernel remains small and efficient. The modular approach provides flexibility and better performance compared to microkernel systems because modules run in kernel space and communicate directly with the kernel. However, if a faulty module is loaded, it may affect the stability of the entire system. Overall, the modular structure offers a good balance between performance, flexibility, and maintainability, making it widely used in modern operating systems. The examples are such as Linux, Solaris. Hybrid operating system structure is designed by combining the features of monolithic kernel and microkernel architectures. The main objective of this structure is to achieve high performance along with better flexibility and stability. In a hybrid system, important services such as process management, memory management, and device drivers run in kernel mode to improve execution speed. At the same time, the operating system is organized in a modular manner similar to a microkernel, which helps in managing and maintaining system components efficiently. Their structure provides the fast performance of monolithic systems while maintaining the modular and structured design of microkernels. However, due to the combination of both approaches, the kernel design becomes complex, making development and debugging difficult. Hybrid operating systems are widely used in modern computers because they offer a good balance between speed, stability, and hardware support. The examples are such as Windows NT and Mac OS XNU kernel.
Today I am going to explain the information shown in this image. The image is about different computer system structures and how we choose the right one. Now I am telling about virtual machine structure. First, let us understand the virtual machine structure. In this structure, one physical computer can run many operating systems at the same time. Each virtual machine has its own application, its own guest operating system. All virtual machines run on a software called a hypervisor. The hypervisor sits on the top of the host operating system and host hardware. Advantages of this virtual machine structure is it provides excellent isolation. If one OS fails, others are not affected. It is very useful for testing risky software. And the disadvantages is resource intensive and requires more RAM and CPU. And examples are VMware, VirtualBox, Exokernel Structure. Next, let us see the exokernel structure. This structure has a very small kernel. The kernel only protects hardware resources. Applications get direct access to CPU, memory, and devices. And advantages of this exokernel structure is it gives maximum efficiency and very high performance. And disadvantages are it is very difficult to program and developers must handle many things by themselves. The OS gives very little support. And the example of this structure is MIT Exokernel project. There are many types of OS structures. Each structure is designed for different purposes. Some focus on speed, some on security, and some on flexibility. There is no single base structure for all systems. Then finally, the image explains how to choose the right structure. There are 8 different OS structures. We consider 3 key factors: performance, security, and flexibility. The best choice depends on requirements. Modern systems usually use hybrid approaches to get the best results. To conclude this, virtual machines are good for running multiple OS safely. Exokernel gives high performance but is difficult to develop. There is no perfect OS structure. The right choice depends on what we need. Thank you for everyone. If you have any questions, I will be happy to answer.